Now, the only way I've seen people struggle in this lab is with the distance measurement. When you have the plank fully extended, then the distance measurement is easy. It's from the point where the back of the car is touching the ground, and then the car has to travel all the way up to the back of the car until the back of the car has reached the height of the table. How far is the car traveling? Well, you just take this mark right from here and that mark right there, and you measure the distance in between, and that's the distance. Here's where people run into trouble. When you angle the board more steeply, the same rule applies. We want to know how far the car has to go from the floor up to the height of the table, right there, and then we just measure the distance in between. And that's the distance. For some reason, every year I run into a little bit of trouble because students, instead of measuring how far the car has to travel to get up to the height of the table, simply measure the length of the board again. Well, the car doesn't even use this whole part of the board up here to get to the top of the mountain, so we don't even need that. We can ignore that and just deal with the part of the board that the car uses to get up to the top of the table. So here we have it. We have roads A, B, C, D, and E, and angles A, B, C, D, and E that are corresponding. And here's the graph that we have to make. In order to make that graph, we're going to need to calculate work, and in order to get our error bars on the graph, we're going to need to work with some uncertainties. Here's a sample calculation for 35 degrees. I made up these numbers. This would be an example. If the force was 150 plus or minus 20 newtons and the distance was 12.2 plus or minus 0.3 meters, our best value uses 150. 12.2 meters gives me 1,830 joules. Here's the max, here's the min. This should look familiar. Feel free to pause the video at this point to look at this more carefully. We look at the spread between the max and the best value. We get 295. The spread between the best value and the minimum, we get 283. Here's our raw number. And if you look at that, we have some uncertainty cropping up here in the hundreds place. So we chop everything else off, leaves us with 1800 plus or minus 300 joules. So in an angle of 35 degrees, the work is 1800 plus or minus 300 joules. So what are you responsible for? Before you come into the lab, you need to view this video until you have a complete understanding of the three types of measurements you must take. Those are the distance up the mountain, the force required to get the car up the mountain, and the angle. You need to know how to do the calculations for work. Finally, have your lab sheet set up. The lab sheet needs a title. You need your name, date, and period in the upper right-hand corner. The controlling question is simply, what is the best way to the top of the mountain? For your procedure, we just need a few lines written, a brief explanation. Your diagram is where you need to take some time. Your diagram needs to show the basic setup. You need to show where you're taking your measurements. And that's angle, distance, and force. Last thing is we need our data section. In your data section, you shouldn't have a blank table. The table should have headings. So you'll have the headings for the table like trial or angle, distance, trial 1, trial 2. These things all need to be filled out. And so you need to do some thinking ahead of time about how you're going to organize that. So when you come into class, you're ready to go. After you've thought through this, you'll also have a lot better idea on what you're going to do in the lab. That should prepare you. Thank you for watching. This has been Mr. Bixel's Tutorials.